our first lecture, Module 1, Part A, 8.1, Brief History of the Internet. When we start, first, I'd like to look at the brief history of computers. As early as 1943 to 1944, so that's the time of World War II, the first digital computer in human history was created, called ENIAC. That's the acronym of this long name: Electronic Numerical Integrator and Calculator. So you can see it is called a calculator, not computer. But at that time, people felt that calculator already very advanced. But what they mean the calculator different from our current calculator. Anyway, so that's the first digital computer. Look at the picture. So it was a big machine, and it was built in the University of Pennsylvania. Actually, two professors, made that big contribution to our technology. The first one, John Macaulay. The second one, Presper Eckert. All right. Next, after that hardware big milestone, so the software milestone. In 1969, Unix operating system and C was developed in Bell's lab. Okay, yeah, that's another big milestone in computing technology. All right, now let's move to the internet, the networking. 1969. So the time, Cold War time. So the free world, we need to fight against the communist Soviet Union. All right. So the U.S. Department of Defense, DoD, they did many projects. Among them, there was the most important one. Look at this. ARPANET project. It was called ARPANET project. So what's the meaning of that? An Advanced Research Project Agency Network. All right. So let's look at this network. First, the birthday of the internet. The exact time was recorded in some way. So look at this team. That's the team created the internet. The time, birthday, October the 29th, 1969, even at 11:30 p.m. because it was written down on some log or diary, what was the mark, or what was the, key event that marked the internet birthday, the birth of the internet? Sending a message through ARPANET. So let's look at this event, historical event. A UCL student did that experiment. His name, Charlie Klein. What he did, sending a message to a remote computer. So that remote computer, so this is Charlie Klein. That remote computer is a Stanford computer. What he sent What he sent? A short message, just 2 characters, LO. So what's the meaning of that? LO, login. In his mind, he tried to, coming up with this login first. Yeah, so LO. Yeah. What is the result? What was the result? The machine crashed. The Stanford computer crashed immediately after it received the message. Yeah. That sounds like a failure, but actually it's not, because it received the message. The remote machine received the message through the ARPANET. So that's a big thing. So that's why it marked the birthday of the internet. All right. So this one, you can see the log, the record we can find to tell us what happened at that time. Yeah. All right. Next, design requirements. So this network should have some important property. Yeah. The network, we know, connecting many computers. But at that time, remember, it's the Cold War time. Our enemy will try to break our network. Okay? All right. So the key property should be withstand attack. Yeah. So that's extremely important. So what's the idea? The key idea, using a decentralized way to get better resiliency. Here you can see the keyword decentralized. Yeah. Why this idea works effectively? Yeah. So let me use a simple example to show. Yeah. All right. Why a decentralized system can control the damage. Yeah. We had that experience in, other places. So we can borrow the idea to this particular project. Yeah. Let me show you this picture. The U.S. aircraft carrier, the newest aircraft carrier, Ford. Okay? And for this big warship, yeah, you can see there are many compartments, many large number of compartments. Those compartments are used to decentralize, some way of decentralize, break the space of that aircraft carrier into many small regions. Yeah. All right. So to isolate the damage. So if one compartment broke, still other compartments still can work fine. Yeah. Yeah. So this kind of simple idea we can use in our internet. Yeah. Similar idea. Yeah. All right. So here we just do that logical reasoning by analogy. Yeah. Yeah. But the details, a lot of details. Yeah. So the technically, we used another protocol, TCP/IP protocol. Yeah. But for this class, this is not networking class, so we do not go to that TCP/IP detail thing. Yeah. We just try to get a background knowledge a little bit. All right. So now you can see sometimes some experience, even in different areas, different things we can borrow to use to solve a big problem. Here, it's a good example. All right, so that's the 8.1.